Hello class, today we're going to be continuing finding limits, but today we're going to be learning how to determine limits using conjugation and by finding common denominators. So the algebra in this can get pretty tricky, so just make sure that you are well aware of what you're doing step by step and try to make your work as neat as possible. So, conjugates. What is a conjugate? A conjugate is a binomial with the opposite sign in the middle. So for instance, if I have square root of x plus 4, its conjugate is the square root of x minus 4. If I have x minus 3, its conjugate is the square root of x plus 3. So when do we use conjugates? We want to use conjugates when we see a square root. Or a radical. Okay? So let's go through some examples. First example, the limit as x approaches 1 of the square root of x minus 1 divided by x minus 1. So here we are trying to find the limit. You can always try to plug it in first, see if you get lucky. 1, you plug it in, 1 minus 1, you get a 0. No luck there. Nothing we can really factor. So I do see a square root, so immediately I think conjugate. Now, I'm going to multiply this fraction by its conjugate. And that would be, let me get orange. That would be square root of x plus 1. And specifically, I want to multiply it by the conjugate of the square root 1. But here's the thing. I can't just arbitrarily change this function by multiplying by the conjugate. The only thing I'm allowed to multiply by is 1. And so to do that, I'm going to multiply both the top and the bottom by the conjugate. Because look, isn't anything divided by itself 1? Yeah. So I'm not changing the function whatsoever. I'm just, well, I'm not changing the nature of the function, rather. I'm just changing the algebra of it. I'm kind of manipulating it so it'll work better in my favor. So here's what you want to do. The side with the square root in the original problem, this top side in this case, we want to multiply that out. This bottom we'll just leave as is for now, and you'll see why. So this equals the limit as x approaches 1 of, and how do we multiply this? Well, we want to we want to FOIL. So I want to multiply this to this, that to that, and then that and that. Okay? So square root of x times the square root of x is x. Square root of x times 1 is just plus the square root of x. Negative 1 times the square root of x is negative square root of x. And then negative 1 times 1 is minus 1. All divided by, and I'm going to leave this just as it is, divided by x minus 1 times square root of x plus 1. Well, you might notice something on the top. If you notice, this positive square root of x and the negative square root of x, those will cancel each other out. So really, all we're left with here on the top, well, on all of it, is the limit, and I know you have to write this every time until you start evaluating the limit. So the limit as x approaches 1 of, where am I? X minus 1 divided by x minus 1 times the square root of x plus 1. And as you can see, this is why I left the bottom factor, because we have a factor on bottom and a factor on top that are the same, which means we can go ahead and cancel those out, which will leave us with just the limit as x approaches 1 of 1 divided by square root of x plus 1. And now, as you can see, if we plug in the limit 1, or if we plug in 1 into this function, we will get the limit now. So this is equal to 1 divided by the square root of 1 plus 1, which is just equal to, square root of 1 is just 1, so it's 1 over 2. And that's our answer. Let's take a look at another example here. And say now we have something like, well, same concept. Let's say the limit as x approaches 16. But now we have the radical on the bottom. Now, as you can see, if I try to plug in 16, well, the square root of 16 is 4, so 4 minus 4 is 0. So we can't just plug it in. Can't factor anything. I see the square root, so immediately I think conjugate. So I'm going to multiply now by the conjugate of this bottom. I'm multiplying by the conjugate of whatever side, top or bottom, has the square root sign. So I'm going to multiply by the square root of x plus 4 and the square root of x plus 4. Remember, what I do to one side, either bottom or top, I need to do the other one because I'm only allowed to multiply by 1. Okay, so let's go ahead and multiply this bottom out, and we'll leave the top this time just factored out as it is. X minus 16 and square root of x plus 4. I only want to multiply the side the side out that has the two square roots. Now again, we're going to FOIL this. So the square root of x times the square root of x is x. Square root of x times 4 is plus 4 square roots of x. And then negative 4 times x is negative 4 square roots of x. And then negative 4 times 4 is negative 16. Oh no, I goofed. I forgot to write my limit. Did you see that? Don't do what I did. I goofed. That should be right there. Okay, now we can go back to the math. Notice, now that these cancel, the 4 square roots of x cancel. So what we're left with is the limit as x approaches 16 of x minus 16 times the square root of x plus 4 divided by x minus 16. And again, we have a pair of factors, one on top, one on bottom, that can go ahead and cancel out, which will leave us with the limit as x approaches 16 of the square root of x plus 4. And now we can evaluate, we can plug in 16 and see what that limit is when x approaches 16. So, equals square root of 16 plus 4, and square root of 16 is 4, so 4 plus 4 is equal to 8. Okay? Let's go over another example. And this time we'll say the limit as x approaches, let's say a big number, 100, of 5x minus 500, don't get intimidated, over square root of x minus 10. So remember what our first step is here. We want to multiply by the conjugate of whichever side, bottom or top, has the square root. In this case, it's the bottom. So I'm going to multiply by the bottom's conjugate. Square root of x plus 10 and the square root of x plus 10. Remember, I'm only technically allowed to multiply by 1, so I have to do it on top and bottom. I'm going to, same concept, I'm going to leave this top part unfactored. sorry, I'm going to leave it factored. So 5x minus 500 times square root of x plus 10, all divided by, now I'm going to multiply these out. Square root of x times square root of x is x. Square root of x times 10 is 10 square roots of x. Negative 10 times square root of x is negative 10 square roots of x. And then negative 10 times 10 is negative 100. Again, you'll notice that this cancels out. This is why we like the conjugate, because things will cancel themselves out. And make the math, oh no, I did it again. Don't do what I do, okay? I can hear my high school math teacher just yelling at me right now. Okay. So these cancel, which will give us the limit as x approaches 100 of 5x minus 500 times the square root of x plus 10, all divided by x minus 100. Now, as you can see, we don't have anything that we can cancel out. And if I try plugging in 100 again, well, 100 minus 100 is still 0. So we kind of run into a problem here. But sometimes we might be able to play with what we have on top. And notice, this 5x minus 500 is very similar to this x minus 100. Well, what if we factor out a 5 out of the top, out of this factor? And you might be able to kind of see what's going on here. If I factored out a 5, I'll get 5 times, and we're really dividing the 5 out, so 5x divided by 5 is just x. Negative 500 divided by 5 is negative 100. And as you can see, now we have the matching factor that we needed in order to cancel it out. So, you can go ahead and do as such. And what we're left with is the limit as x approaches 100 of 5 times square root of x plus 10. And now we can just plug in the 100. So that equals 5 times the square root of 100 plus 10. Well, the square root of 100 is just, square root of 100 is just 10, so 5 times 10 plus 10, 5 times 20, we get 100. Okay? So the trick here was we had to notice the similarities here and know, oh, well, we can factor this thing out and it'll give us this. So remember, always play with the mathematics. Try to make it work for you. Okay? Yeah. So that's my hint there. Okay. Moving on to determining limits using common denominators. So that was conjugation. And here's a little trick when finding common denominators. And that is, we need to remember the difference of squares. So the difference of squares states, and we went over this, I wrote it a little different. I wrote it with x last time. I didn't really mean to. This is a much cleaner way of writing it. A squared minus b squared is equal to a plus b times a minus b. So we need two squares being subtracted from one another, and then we can put it into this form. And that will come into play when we are doing some of these. So let's go into some examples here. Let's see, where's my blue? Okay, let's say we have the limit as x approaches 3. And we have 1 over 3 minus 1 over x, all divided by x minus 3. So let's kind of go through this. Our first step, we always want to see if we can plug something in, right? If we plug this 3 in, on the bottom we'll get 3 minus 3 equals 0. Can't do that. There's nothing, and there's nothing here we can factor, really, like when we're working with factoring. I don't see a square root, so we won't be dealing with conjugates. But I do see some fractions here, and they're being a little extra because there are two sets of fractions, right? We have a fraction divided by something else. So what we want to do is look at the top, and let's try to get common denominators here. So remember, the denominator is the bottom part, so we want to get a common bottom part here. And I'm not talking about this bottom part, I'm talking about this bottom part. So what we want to do is we want to multiply by each other's denominator to get common denominators. Which means I want to multiply orange this by x, and remember, I'm only technically allowed to multiply by 1, so I need to multiply by x over x, okay? Because anything divided by itself is just 1. Over here, I want to multiply by 3, the opposite denominator, but I'm going to multiply by 3 over 3, which will give us, I know it looks really ugly, it's going to look a lot nicer. That's kind of our point. We're trying to make these things look nicer and nicer. So equals the limit, I remembered this time, of x approaches 3 of, let's see, x times 1 is just x, divided by x times 3 is 3x, minus 1 times 3 is 3, divided by x times 3, which is 3x. And all over x minus 3. Well, now that they have common denominators, we can actually write it a lot nicer. We can put it over one division bar and just rewrite it like this. X minus 3 over 3x divided by x minus 3. Now let's think about this. We have this thing being divided by this thing. Well, remember, do we recall the idea that dividing by something is the same as multiplying by its reciprocal? Well, technically, we can think of this thing as this, right? We have this, I'm going to make this division bar thicker so we can kind of tell it's there. We have this thing divided by this thing. So let's multiply this by the bottom's reciprocal, okay? So I'm going to have the limit as x approaches 3 of x minus 3 divided by 3x times 1 over x minus 3. And would you look at that? This will actually cancel with this. So when it cancels, oh, sorry, this is 3x. So when it cancels, we're going to get the limit as x approaches 3 of 1 over 3x. And then now we can plug in that 3 and we won't have a problem. So 1 over 3 times 3, which is just 1 over 9. Oh boy. That is the limit of this thing. So let's go over another example. And this one will look a little different. Let's see. Well, no, this one will look the same. Well, similar. But we're going to kind of do some shortcuts this time. Okay. Oh my gosh. The limit as x approaches 5 of this ugly mess. So again, let's get common denominators on top. We're going to multiply by the opposite denominator. So this over here, I'm going to multiply by 5 over 5. This one over here, I'm going to multiply by x over x. So that's going to bring us the limit as x approaches 5 of, let's see, well, we know the bottom is going to be the same, right? So we know that the bottom is going to be 5x, right? 5x, 5x. So just like up here, when we had 3x and 3x, we can just simplify it to this. I'm just going to take a shortcut and simplify this to 5x. And the top is going to be 1 times x, which is x, minus 1 times 5, which is 5. All divided by x minus 5. Well, again, remember, dividing by something is the same thing as multiplying by its reciprocal. So we have this one up here divided by this, which is technically over 1. So we can rewrite as the limit as x approaches 5 of x minus 5 over 5x times 1 over x minus 5. And again, you can see that this cancels out. And we're left with the limit as x approaches 5 of 1 over 5x. And then finally, we can just plug it in. Plug in 5. We get 1 over 5 times 5, which is 1 over 25. Okay? Boy, we're really making some headway. Let's do a couple more examples, and then I promise I will get out of your hair, or I'll just end the video, I guess. Let's see. Okay. So this example, the limit as x approaches 2 of 1 over 4 minus 1 over x squared divided by x minus 2. So again, we can't plug in 2 or else we'll get 0 at the bottom. Let's find common denominators, okay? So I'm going to multiply this left side by x squared over x squared, the opposite denominator. And over here, I'm going to multiply by 4 over 4. So let's multiply this out and see what we get. And as you notice on the bottom of this top fraction, we'll get 4x squared. So we'll get a 4x squared here, 4x squared there. We can just write on top of each other. And on the top, we're going to get x squared times 1, so it's x squared, minus 4 times 1, so 4, divided by x minus 2. Now, unlike with our last problems, you may have noticed that the top was the same as the bottom when we multiplied by the reciprocal. So let's go ahead and do that. When we multiplied by the reciprocal, we can just cancel it out, right? But that's not the case here. The case here is that they're not the same, so we can't cancel it out. But remember a difference of squares. If we have something like a squared minus b squared, it's equal to a plus b times a minus b. And if you notice, x squared is a square, and 4 is a perfect square, and they're being subtracted. So let's put it into this form. So the square root of x squared would be x. The square root of 4 is 2. So we can rewrite this thing as the limit as x approaches 2 of this. This will turn into x plus 2 times x minus 2 over 4x squared times 1 over x minus 2. And now we have two factors that will cancel this extra x out at the bottom. You might be able to see if we plugged in 2 here, we'd still get 0. If we plug in 2 here, 0 times whatever this would be 0. So we still have to cancel it out. But cancel it out, and we get the limit as x approaches 2 of, well, x plus 2 times 1 is just x plus 2 divided by 4x squared. Now when we plug this in, we won't get a 0 on the bottom. So we're going to plug in 2 for x, so 2 plus 2 divided by 4 times 2 squared. And we could just simplify this. Remember, we want to square before we multiply. So the top is going to be 4. The bottom, 4, this is going to be 2 squared is 4. 4 times 4 is 16. And if you want to reduce, this reduces to 1 over 4, just like that. All right, let's go over one more example. And this one will be the limit as x approaches 0 of 1 over x plus 2 minus 1/2 divided by x. So again, let's multiply by each other's reciprocal of, or not, that's reciprocal, by the other one's denominator. So in this one, we're going to multiply both sides by 2, and over here, we're going to multiply both sides by x plus 2. And that's going to give us the limit as x approaches 0. Is it safe to say, just how we made the shortcuts up here with this, that if we're going to have 2 times x plus 2 and 2 times x plus 2, we're going to have a common denominator now of 2 times x plus 2, just like that. And then on the top, we're going to have 2 times 1 is 2, 1 time minus 1 times x plus 2, which is just x plus 2. Now, I put this in parentheses because it's minus. I'm going to have to eventually distribute that negative, so that's why it's important to put it in parentheses. And then all divided by x. So you may be tempted to cancel this. I wouldn't just yet. Let's actually multiply this out. So, actually, no, you can't cancel it because it's connected by addition or subtraction. That's why you don't want to. I knew there was a reason why you didn't want to, but it's because you can't. Okay, so the limit as x approaches 0 of 2, well, negative times x is minus x. Negative times 2 is minus 2, divided by this mess. We'll just leave it unfactored as for now. And then all divided by x. So again, we're dividing by this thing like x over 1, so let's multiply by its reciprocal to get the limit as x approaches 0 of, and look what happens here. Does 2 and negative 2? They're going to cancel out. So all we have left is negative x. So we're going to have negative x divided by 2 times x plus 2 times the reciprocal of this, 1 over x. And look what happens. Now this x, these x's, can cancel out. But I still have this negative out here, so be careful. So this is going to turn into the limit as x approaches 0 of negative times 1, so negative 1, over, and I guess we can multiply this now if you want. 2 times x is 2x. 2 times 2 is 4. And then notice that if we plug in 0, we're going to get negative 1 over 2 times 0 plus 4. That's going to be negative 1 over, that's going to be 0, so just negative 1 over 4. And that's that. So that is how we find the limit by using common denominators. And I realized as I was going through this is a lot of information, so we're going to actually split up the lesson. So on your worksheet for today, or I guess today, Friday, depending on when you're watching this, just focus on determining using conjugates. And then on Monday, we'll focus just on finding the denominator. Okay? I really should have split it up, but I didn't have the foresight for it. So that's that. And I will give you directions for it also, a reminder. So that's that. Have a good day.